Okay, lesson 3.7. Our learning objectives are to write an equation of a line given a description of a relationship. And you might feel like we've done a lot of that already. So objective 2, write an equation of a line that models data from a table. 3, write an equation of a line from a graph of a line. And graph a line by plotting points. So later on in this particular section, we're going to use the idea of blood alcohol concentration and how alcohol leaves the system. So it's one of the few drugs that leaves your system linearly, so that'll be a good model for that. All right, let's go ahead and get started. A student organization you're involved in is planning a year-ending pizza party to celebrate another successful year on campus. As chair of the planning committee, you've wisely worked a deal with the local pizza place to provide large pizzas at $9 each. The budget will allow at most $175 to cover the food. And of course, you like to know how many pizzas you can get and stay under budget. So we'll attack the problem in several different ways. So number 1 says use a numerical calculation. Include all details and don't forget to write the number of pizzas you can buy. Really, another way of them saying this is use your common sense. Pretend that you didn't know any algebra. What would you do? Well, if you had $175 and those pizzas cost $9 each, well, you're going to go ahead and divide. And we get roughly 19.4. Okay, so since you can't buy 0.4 pizzas, you can afford at most 19 pizzas. And then they ask you to write an equation that represents the total cost, C, of ordering 9 pizzas. So each pizza costs $9, and you're ordering P pizzas. It says, what does this tell you about how the cost varies when you change the number of pizzas ordered? Well, because it's in the form of y equals kx, we could say it varies directly. Okay, so the next thing they want you to do is complete the table, then use it to estimate the number of pizzas you can buy. So we're really just looking for 9 times 0, 9 times 5, 9 times 10, etc. So go ahead and pause the video and fill out the chart. I'll do the same. Okay, so if you just multiplied 9 times the number of pizzas bought, you should get the same thing I did. Now number 4, it says use the information from the table to draw a graph with the number of pizzas on the horizontal axis and the total cost on the vertical axis. Make sure you label the scale on each axis and use your graph to estimate the number of pizzas that can be bought for $175. I know I didn't answer that question for number 3, but when we're done, we'll look at both of these. Okay, so my input is 30. I go up to 30. Let's see what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go ahead and say 30 divided by 10. Let's go up by 5. That sounds like a good idea. So 5, 10. Oops, I need my... So 5, 10, 15, 20, 25, 30. It's not a great scale, but it's all right. Okay. And then I'm going up to $270. Yikes. So let's round that up to 300. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 300 divided by 10 will give us roughly 30, but that's kind of awkward, don't you think, to go up $30? So let's go ahead and round each hash mark to 50. So that'll be 50, 100, 150, 200, 250, 300. Now I know this doesn't span the whole length of and width of the graph, but we have to look for ease of graphing too. So let's go ahead and plot our points. We have 500, 545. Boy, I can hardly read my writing. So that'd be about, oops, about right here. Then 1090. And then 2180. Oh, 15135, sorry. 2180. And then 25225. And then 3270.